taken. Doesn't mean I didn't like our old example, but the fact that the new example, you can keep the old example in there, that's fine. I'm just showing you guys, okay, sorry, Con updated his examples. And it totally makes sense why. He wanted, once again, a function that went below. For those of you just joining us, we did go ahead and follow the link to watch CalcAB, just a small snippet. Specifically, what we wanted to look at was area between curves. Literally, our section title up here at the top is exactly what he calls this part that I started to watch that I have a screenshot of. But over on the right-hand side, our goal is to find the area between two curves. Now, I do have two different little categories, subcategories underneath that. One of them is natural. Hey guys, if something naturally occurs, do you have to like force it, or is it kind of just there? She just exists. Now, the bounds that he showed over here, which I think there was like an A and B that was here-ish, right? There was an A and B. Or a little bit later, he chose like a C and a D that were over here-ish, right? The bounds that he chose are what we would call defined bounds. They were just kind of random. He just said like, oh, here's an A and B. Ah, here's a C and D. That's what we would call defined bounds. It would need to be given to you. And it wouldn't really, like on the picture, it wouldn't really make sense. Like, why were there bounds there? I don't know, because he wanted a portion where they were both above, and he wanted a portion where they were both below. But it didn't naturally occur. The natural bounds are going to be basically intersections. So if you, like the one that we had originally, right? If you had this function, and if you had this function, where are the natural bounds for the area in between? For the graph that you guys drew, the natural bounds would be the intersections. Do you see it? Because what's between them? Oh, well, that's between them because that's, okay, so naturally bounded regions will just be between intersections. And so for intersections, you can find intersections by setting f of x equal to g of x, right? So if they don't give you bounds, you're probably finding them yourselves. And you're finding them yourselves by setting f of x equal to g of x, and then you're solving with some sort of algebraic process. Maybe factoring, maybe with a calculator. That's actually going to happen quite a bit on the AP. Not quite a bit, but it will happen on the AP using your calculator to find intersections. So the steps. You guys already wrote these down too. These down as well. First, identify which curve is most positive, which is the highest one, or which is the farthest right one. We haven't talked about area between curves that's horizontally oriented, but we'll get there. But it's either the one that's highest or the one that's farthest right. Number two, identify the bounds. Natural, you're finding them yourselves. Defined, they're given to you. So if you want to write it this way, defined, that's going to be something that's given. Natural, that's something that you have to find. So either they're given to you, they're defined, or it's up to you to find them. And then we have to be careful that we must split up integrals if the curves ever switch orders. Or, all right, here's a quick little note to add. Or use absolute value. Let's not say 2. As a shortcut. Or use absolute value as a shortcut. Or use absolute value as a shortcut. But guys, with absolute value, don't we sometimes have to split up things also? Sometimes you have to split up things also. Let me go ahead and zoom in because I know a few of you guys, it's a little hard to see all the writing when it's zoomed out to 2 pages. I saw a few of you squinting. I apologize. So what did we add? We added for the intersections. What I'm talking about is just set the two functions equal to each other and solve. Sometimes there's 2 intersections. Sometimes there are 3 or 4, and we have to be aware of that. But otherwise, our steps are to figure out who's the most positive, farthest right. Figure out the bounds. Are we either just doing what's given to us, or are we finding it? And then use absolute value as a shortcut. Is a possibility when needing to maybe split up an integral if the curves ever switch orders. So let's take this example. Area between, they have to give us 2 functions, and they do. They give us f and they give us g. So we have f of x equal to we have g of x is equal to x cubed. Yeah? Two different functions. Step number 1 says, figure out who's on top. I don't know who's on top. Is x cubed on top? Is x squared on top? Okay, so maybe Tyler's saying maybe we should think about the bounds and get a little picture. But how are we going to figure out the bounds? We have to think natural. Well, we have to think natural because what's not there? There's no picture telling us what to do, right? Sometimes in homework you'll see a picture. There's no picture telling us what to do, number 1. Number 2, it doesn't say from x equals to x equals. It is not telling us anything. So, all right, it must be natural. So to find our natural bounds, we're going to go ahead and think intersections, yeah? All right, natural bounds, think intersections. Intersections, what did I tell you to do? Set f equal to g, right? Is one intersection. Struggle. What do you have to think about whenever you have polynomials? Don't go that crazy. I just mean whenever you have a polynomial expression, whenever you have degrees of x, like no ln's, no e's, nothing like that, how do we always need to solve whenever there are terms of a polynomial? Get them all to one side and factor. Get them all to one side and factor. So remember, get one side equal to 0. Polynomials, always get one side equal to 0. Because Nathan right away saw 0. That's great, but what about 1? If you factored, do I get 0 and 1? Does that make sense? Okay. So polynomial expressions always factor in order to find our zeros. So I know I'm looking at x equals 0 to x equals 1. So right away, if I'm building my integral for area between, yeah? If I'm building my integral for area between, I know so far I'm going from 0 to 1. Okay, so I can go ahead and, wait, can't we even plug in and figure out what's going on at 0 and 1? At x equals 0, what point do we have? Because they should be shared. So at x equals 0, plug it in, either one, 0, right? And, okay, at 1, plug it in. Okay, so 0, 0, and 1, 1, right? So we know down here on our function or on our graph that we're going to go ahead and have 1, 1 be a point, 0, 0 be a point. What am I trying to figure out? Who's on top? Who's highest? Who should go first in the subtraction? Well, how are we going to know, kiddos? 2 ways. Number 1, what's something in between 0 and 1? So couldn't we technically plug in 1/2 and say, okay, well, who's higher? So plug in 1/2 squared. What's 1/2 squared? 1/4. So I have that guy who's going to be, okay, well, there's a half and there's a fourth, right? Okay. So that's where the x squared guy goes. Okay, where's x cubed going to go? What's 1/2 cubed? 1/8. Oh, who's on top? X squared's on top. So x squared's going to be going like that. X cubed's going to be going like that. Ooh. How did I know? Well, I plugged in 1/2. And x squared was a 4th. X cubed was an 8th. All right, well, fine. X squared's on top. So that's one way of doing it. You could throw in the x squared first in the subtraction, and then we have x cubed. But can someone look at the steps that I wrote down in your notes? What was the little extra piece that we wrote down just a second ago under step 3? Split integrals, order is swap. But what did I say we could use as a shortcut? Absolute value. Area between, if we're always supposed to choose the higher minus the lower, area between is always needing to be positive. Oh. Couldn't we just have said, can we just go from 0 to 1 and just do the absolute value of whatever way we want to subtract? Even if we had picked wrong and we had done x cubed minus x squared, If we had just guessed one and been like, oh, no, that one minus that one. Yay, let's go. Did I guess right? No. Make it all better. It's going to make it all better. Over here, we would actually go solving in the proper order. So we would actually go, ooh, how do we solve the integral? What am I doing right now? I'm integrating, right? I'm anti-deriving. So I would anti-derive x squared using the power rule, and anti-derive x cubed using the power rule. I'd go ahead and plug in 1, so I'd have 1/3 minus 1/4. Plugging in 1. Plugging in 0. 0 minus 0. Oh. I would end up with, common denominators. I know. Stick it to the man, which is how I tell you to stop on a test. But for illustration's sake, 1/3, wouldn't that be 4/12? And 1/4, wouldn't that be 3/12? Did I end up getting a positive? Because I put the higher one first. I ended up getting a positive. But guys, if I was to go over here and do this side, technically I would have absolute value. Shouldn't I look for intersections in between? But what are my zeros? Remember, absolute value split up at the zeros? Didn't I just find that over here? My zeros of the subtraction are the same thing as my bounds. So the nice thing is, if you've already split up with your intersections, you don't have to worry about having to split up the absolute value anymore. So you could go ahead and just pull that absolute value out from 0 to 1 of x cubed minus x squared. The intersections are the zeros, so therefore I've already split up as much as I need to. We would have solved and gotten x to the 4th over 4 minus x cubed over 3, but what would be still outside that whole thing, guys? Yeah. So I would still have to solve from 0 to 1, but the nice thing is I have absolute value just chilling out there, keeping it safe. And when I go to plug in, I would have 1/4 minus 1/3 minus 0, basically. But I still have absolute values keeping it safe. And when I subtract, I would get negative 1/12. But the absolute value is keeping it safe. Because at the very end, what am I going to do now that I have a negative? Make it positive. So pause. Was it helpful to know who was on top? Maybe. Was it helpful to have a picture to say, oh, we're going to subtract? Maybe. But what can we kind of just do instead? As long as we find the intersections and make sure that we split up by those intersections, we can just throw in absolute values, which, because of the intersections, can just come out. We can just solve and say, hey, if you're positive, I guessed right as to who went first. And if you're negative, I'll make you positive. Kiddos, tomorrow we're going to play, and finish up this section. Homework's due on Wednesday. I apologize for not having the backboard updated. Absolute value always behaves the same when it's in there. We're just putting it in, so we just have to be careful.
Yeah, but does the equation determine whether we can use it or not, or can it be like...
For area between, we can always use it.
All right, cool.
Yeah.